So let's set up a relationship between the variables x and y. So let's say, so this is x and this is y. And when x is 1, y is 4. And when x is 2, y is 8. And when x is 3, y is 12. Now you might immediately recognize that this is a proportional relationship. And remember, in order for it to be a proportional relationship, the ratio between the two variables is always constant. So for example, if I look at y over x here, we see that y over x, here it's 4 over 1, which is just 4. 8 over 2 is just 4. 8 halves is the same thing as 4. 12 over 3 is the same thing as 4. Y over x is always equal to 4. In fact, I can make another column here. I can make another column here where I have y over x. Here it's 4 over 1, which is equal to 4. Here it's 8 over 2, which is equal to 4. Here it's 12 over 3, which is equal to 4. And so you can actually use this information, the ratio between y and x is this constant 4, to express the relationship between y and x as an equation. In fact, in some ways this is, or in a lot of ways, this is already an equation, but I can make it a little bit clearer if I multiply both sides by x. If I multiply both sides by x, I am left with, well, x divided by x, you just have y on the left-hand side. Y is equal to 4x. And you see that's the case. X is 1, 4 times that is 4. X is 2, 4 times that is 8. So here you go. We're multiplying by 4. We are multiplying by 4. We are multiplying by 4. And so 4 in this case, in this situation, this is our constant of proportionality. Constant. Sometimes people will say proportionality constant. Constant of proportionality. Now sometimes it might even be described as a rate of change. And you're like, well, Sal, how would 4 be a rate of change? And to make that a little bit clearer, let me actually do another example, but this time I'll actually put some units there. So let's say that x, let me do this, I already used yellow. Let me use blue. So let's say that's a measure of time, and y is a measure of distance. Or let me put it this way. X is time in terms of seconds. Let me write it this way. So x is going to be in seconds, and then y is going to be in meters. So this is meters, the units, and this right over here is seconds. So after 1 second, we have traveled, 7 meters. After 2 seconds, we've traveled 14 meters. After 3 seconds, we've traveled 21 meters. And you can verify that this is a proportional relationship. The ratio between y and x is always 7. 7 over 1, 14 over 2, 21 over 3. But I want to write that in terms of its units. So y over x is going to be, if we look at this point right over here, it's 7 meters over 1 second. 7 meters over 1 second, or it's equal to 7 meters per second. If you look at it right over here, if you say y over x, it's 14 meters in 2 seconds. In 2 seconds, well, 14 over 2 is 7. 14 over 2 is 7, and then the units are meters per second. So that's why this constant, the 7, in all of these cases, we have y over x is equal to 7, that this is also sometimes considered a rate. And over here it's very clear. This is my distance per time. Now if I wanted to write it generally, I could say that, look, if I'm dealing with a proportional relationship, it's going to be of the form, I can always construct an equation of the form either y over x is equal to k, where k is some constant. In this first example, k was equal to 4. In this second example, k is equal to 7. Or you can just manipulate it algebraically, multiply both sides by x, and you would have y is equal to kx, where once again k is our constant of proportionality, or proportionality constant. So this is a really, in some ways it's a very simple idea, but in a lot of ways you'll see this showing up many times in your mathematical career. It's neat to be able to recognize this as a proportional relationship.